Hello friends, how are you? Hope you guys are all well. Welcome to my YouTube channel. Today my topic is, as you can see this. Okay, so before moving to my topic, I request you to please subscribe my YouTube channel and don't forget to watch my previous videos. Okay, so moving to my topic, Newtonian gravitation, free fall acceleration and the gravitational force, gravitational potential energy, escape speed, Kepler's first law, Kepler's second law and Kepler's third law. Newton's universal law of gravitation, the apple was attracted to the earth. All the objects were attracted to each other in the same way the apple was attracted to the earth. Okay. After that, every particle in the universe attract every other particle with a force that is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Okay, square of the distance between them. F is equal to g is constant of the universal gravitation. G is equal to 6.673 to power minus 11 Newton meter square per kg square. This is an example of an inverse square law determined experimentally Henry Cavendish in 1798. Okay, after that, universal gravitation, the force that mass 1 exerts on the mass 2 is equal to and opposite to the force mass 2 exerts on the mass 1. The forces form a Newton's third law action reaction. The gravitation force exerted by the uniform sphere on a particle outside the sphere is the same as the force exerted if the entire mass of the sphere were concentrated on its center. Billiards and one the three 0.3 to 0.3 kg billiard balls are placed on a table at the corners of the right triangle. Find the net gravitational force on the cue ball. Find the components of the gravitational force of the M2 on M3. Okay. In the next slide, you can see free fall acceleration. Have you heard that this calm astronauts are weightless in space, therefore there is no gravity in space? It is true that if an astronaut on the International Space Station ISS tries to step on a scale, he or she will weigh nothing. If it may seem reasonable to think that if weight is equal to mg, since weight is equal to 0, g is equal to 0, but this is not true. Okay, if you can stand on a scale in the elevator and then cables are cut, you will also weigh nothing. M is equal to n minus mg, but in free fall a is equal to g, so the normal forces n is equal to 0. This does not mean g is equal to 0. Astronauts in orbit are in free fall around the earth. It is just as you would be in the elevator. They do not fall to the earth, but only because of their very high tangential speed. Consider an object of the mass m near the earth's surface. Acceleration g during the gravity we find at the earth's surface. Gravitational force, consider an object of the mass m at a height hp above the earth's surface. The acceleration due to the gravity g will vary with altitude. Gravitational potential u is equal to mgy is valid only near the earth's surface. For the objects high above the earth's surface, an alternate expression is needed. Zero reference level is infinitely far from the earth, so the potential energy is everywhere negative. Energy conservation, E is equal to k plus u, gives us 1 over 2 mv square minus g mg m over r. Energy of an orbit, consider a circular orbit of a planet around the sun. What keeps the planet moving in its circle? It is centripetal force produced by the gravitational force. That implies that making this substitution in this expression for the total energy. Note that the total energy is negative and half is the negative potential energy. For an elliptical orbit, r is replaced by a. Okay, so I think this is enough for today's topic, so time to go. Goodbye, meet you in the next video.